In this video, we'll discuss points, lines, and planes. Now, a point is a very specific location in space. There's no shape or size, it's just a location. But we do use a dot with a capital letter to help us recognize where that point is. And we never want to use the same point or the same letter twice for different points in the same sketch or construction. So if we had these 3 points here, we wouldn't want to label that third one A, we would want to label it something different like C, so we could be talking very specifically about that location. Now, a line is a straight mark that goes on in both directions with no end. It represents length, only length, one dimension. And when we draw it, we're going to draw double arrows on the ends to help us represent going on without end. We can label it either with a small script letter by the line or with 2 capital printed letters representing points on that line with a double arrow over top. So if we have this line here, we see there's 3 points, A, B, and C. We can choose either 2 points and we can order them either way we want to be able to call this a line. So we could say line AB, line CA, line CB, line BC, it does not matter. But what we do not do is we do not put all 3 points together. We only need 2, and that automatically represents a line. In contrast, a segment is when we have 2 points and all the points between. There is a definite end to that segment. And so when we label it, we're looking at having a point on each end and then drawing the segment between, and then we're going to label it with those 2 endpoints. Again, order doesn't matter because it's not directionality here. So we could say this is segment AB or segment BA. But it's telling us those 2 endpoints with everything between on that straight segment. Now, a ray is going to be a straight mark that goes in one direction without end. And it's important to recognize here that we have a definite endpoint. And that endpoint is how we start labeling as we're going to do it. We're going to use that endpoint and then a second point for which it goes through, and then put the single arrow pointing to the right to help us do our order. And order is important because when we look at this ray, this is ray AB because it starts at A and goes through B. We would not label this BA because that would mean it starts at B and goes through A forever, and that's not true. It goes starting at A through B and then continues to go onward. So let's look at those terms and add a 4th one in here. If it's got double arrows, that's talking about a line. If it's a flat bar, that's talking about the segment. If it has a single arrow pointing to the right, that's talking about the ray. And if there's nothing over top, we're talking about the distance or measure from 2 points. And so that's important. When we have nothing, this is a measurement. So we want to make sure if we're talking about objects, we put the right symbol over top. Now, that also leads to the idea of having other things like collinear points. This is when the points are all on the same line, even if the line is not visible. For example, if I look at these 2 sets, on the left, these 3 points would be collinear because I could draw a line through them. However, on the right, if I try to draw a line through, I'm going to end up with a triangle, and that makes them non-collinear. But that's an important piece because that helps us build planes. And a plane is a flat surface that extends in 2 directions with no end. So this is length and width, just no height. And we often will see this drawn like a parallelogram. So it looks restricted, but we have to remember that it's really going on forever in both directions. We label this either with a capital script letter or at least 3 non-collinear points. So typically you'll either see it listed with 3 non-collinear points or 4, but it just needs to be at least. So if I look at my image now, I could call this plane M, or I could call it ABC, plane CBA, any of those combinations. And if I had a 4th point, I could add that in as well if I wanted to. So if we have a plane, we can also talk about being coplanar. And just like collinear meant that there are 3 points on the same line, this is when we're talking about objects that are on the same plane. And we have to remember that they have to be non-collinear objects so that we can recognize the idea of calling something a plane. So we may be able to say it's collinear. If it is collinear, it's automatically coplanar, but normally we're talking about looking at objects that aren't collinear. And we don't have to have the plane visible to actually be able to discuss that plane. So let's look at a couple examples. If we looked at points A, B, and C, we see those 3 points fall on that top face of my cube here, and we think about it going in both directions, length and width, forever, and it would include those 3 points, so we'd say yes, that is coplanar. If we said A, B, C, F, however, F is down here. It is not on this face or on that plane, so that would be no, they are not coplanar. What about if we said H, G, F, E? In this case, we're talking about these 4 points that represent the bottom face of this cube, and again, it would extend forever, and all 4 of those would fall on that face. What about E, H, C, B? So this one makes us have to think a little bit more, because it's like, well, I don't have an actual face to my cube, but if I think about the diagonal, and I think about how these points are lined up, I could take a piece of paper and I could take it and slice it down from BC through HE, and all 4 points would fall on that diagonal plane. So we would say, yes, this is coplanar. Now, what if we said AGF? That's just 3 points. But remember, it takes just 3 points to be non-collinear, therefore they are coplanar. And I've got the triangle here to represent that they are non-collinear, but technically the plane for which they exist on would be FGAD. Just like we talked about EHCB a minute ago, this triangle would actually extend out both length and width, so going on forever from F to G and through A to D, and then all the way up D through G, A through F, that kind of paper, thinking about that flaring out to make it go in all directions. And let's look at one last one here, CBFH. So if I look at this, CBF, that's this right-hand side. H is over here by itself. So it is not falling on that same plane there, so we would say these are no, they are not coplanar.